Hi everyone, it's Math with AUB, day number 5 for the preparation of NTHP NET and ECAT. I have selected some questions for you. Each question has the capacity to give you a jolt and jerk. They straighten your thinking. Let's see and find out what is our question number 1. Question number 1 is based on quantitative mathematics. It reads as, if x is equal to 3 plus 2 times root 2, find the value of root x minus 1 over root x. X is there. On first glimpse, it seems to be really very easy and nice, but in reality, it is harder to crack. X is this one. X is 3 plus 2 under root 2. You at once realize the value of 1 over x is 3 minus 2 under root 2. But there must be a safety. Apply safety on it. Square of first is 9. Square of second is 8. Their difference should be 1. Their difference should be 1, must be 1 in order to get 1 over x directly. Otherwise, you have to rationalize. In that case, that's x. Their square difference is 1. So I can write direct 1 over x is changing the middle sign. That's r1 upon x. If you add them up, x plus 1 over x, it will result in 6. It will result in 6. We cannot find square root of this one. Square root of this one. On the other hand, on the contrary, we take this one, square it, put this value, utilize this value. Take this value that we have to find. Root x minus 1 over root x. Squaring both sides, we have x squaring, it's tantamount to x minus twice root x 1 over root x plus 1 over x. Cancelled out, x plus 1 upon x minus 2. Value of this quantity is equal to 6 that we have find out. 6 minus 2, 8 are 4. That is the value of root x minus 1 over root x whole square is equal to 4. We are asked to find the value of root x minus 1 over root x, taking the square root of this one, and we are going to get through. This question is solved by utilizing a retrospective fashion. So root x minus 1 over root x is equal to plus minus 2. That's our answer. X, you can directly rationalize the denominator 1 over x, keeping in mind that the square difference must be 1. If not, then you have to rationalize or by orthodox method. You have to find this one out. That's our value of x plus n. We are not in a position to find square root of this one. On the other hand, take this quantity and square it. Take this quantity and square it. So you are going to have some value of x plus 1 over x. Utilize here. It is that 4 is the value of root x minus 1 over x whole square. We are interested in the value of root x minus 1 over root x, not square. Taking the square root, that's our answer. Let's see and find out question number 2. We are asked to find domain. In case of domain, you have to keep 3 things in mind. In root, we cannot afford negative values, any negative quantity. In case of denominator, denominator doesn't vanish, denominator doesn't equal to 0, and in base, in log, base shouldn't be negative. So there is only root, handle it. We need x square minus 1 must be greater than or equal to 0. X square minus 1 greater than or equal to 0. It means x square must be greater than 1. We have to take these values. What happens if x square is less than 1? That is the portion that we have to delete, that we cannot afford. Taking modulus on that side, it's 1. Open up, minus 1 is less than x, less than 1. That is the blind spot of this function. If we are going to take any value from minus 1 to 1, between minus 1 and 1, it will give us a negative quantity. Say suppose take 0, 0 minus 1, 0 minus 1, it results in minus 1. So we cannot afford that interval, that open interval. We have to exclude all the portion between minus 1 and 1. We have to exclude all the portion between minus 1 and 1. Outright this one, let's see its fashion. It can written as negative infinity to minus 1 inclusive. We can take 1, we can take 1. Union from 1 to positive infinity. That I have excluded all the portion between minus 1 and 1. All the portion between minus 1 and 1 have been excluded. What happens if same question is given to you in that fashion? 1 over x square minus 1. Then what we have to apply? We have to exclude this minus 1 and 1 as well. Please think over it. I leave this as your assignment work. Moving to our final question. Sine, its argument is twice cos inverse x. We have to prove it is equal to 2 times x root 1 minus x square x. Take this quantity cos inverse or cos is equal to, suppose a. Taking cos inverse here, x is equal to cos a. Whatever the situation is, you must have the value of cos a as well as sine a. Utilizing the tiny identity of trigonometry, sine square a plus cos square a is equal to 1. What is the value of cos a? X. Sine square a plus value of cos x is x square is equal to 1. Solving for sine a, sine square a is equal to 1 minus x square, or sine a is equal to root, taking square root both sides, 1 minus x square. So we have sine a is equal to 1 minus x square. Take this side, put values. We have sine twice cos inverse x is equal to a. Cos inverse x is equal to a. It is equal to a. Let me write a. Now we are familiar from the double angle identity. Sine 2a is given by 2 sine a cos a. 2 sine a cos a. What is the value of sine a? That we have just utilized. Find out 1 minus x square. What is the value of cos a? It's our x. It's our x. So that is the required answer that we have to prove. Write in that fashion. 2 times x 1 minus x square. It's our proof in that case. It's my tiny effort on day number 5 for you. What is coming next for you? Nobody has idea. Keep on guessing. I am coming on day number 6 tomorrow. It's all by itself. Back.